Good afternoon. It's fantastic to see all the enthusiasm. So welcome to our convocation. I'm Joe Sheppard. I'm the Vice President of Student Affairs, Professor of Aeronautics and Mechanical Engineering. I hope you're just as excited as I was 43 years ago today when I came here as a graduate student. And so I hope that you're looking forward to a fantastic experience. So I know as for all the parents here in the audience that you have both a sense of separation and perhaps a sense of anticipation, and you're going to go home and convert the bedroom into a rec room. So, so this event, Convocation, that marks the beginning of our academic year and a chance for our community to gather together and welcome you as new members and celebrate your joining us. And for all of our families and friends here in the audience, you'll have a chance to learn something about what makes Caltech the very special and exciting place that it is. And for all of you incoming students, this will give us an opportunity to set the tone for your journey of personal growth and the intellectual journey that's at the core of the Caltech experience. There's no one better to set that tone than our president, Tom Rosenbaum. Dr. Rosenbaum joined Caltech in 2014 following a distinguished career as a professor and the provost at the University of Chicago. Caltech has always had a tradition of having working scientists and engineers leading the institute, and Tom follows in a proud set of footsteps here. In Tom's laboratory, he and his students study the quantum properties of materials at extreme conditions, temperatures only 1,000th of a degree above absolute zero, magnetic fields 300,000 times stronger than on the Earth's surface, and pressures up to 450,000 atmospheres. Despite the challenge of creating such extreme conditions, I suspect at times Tom finds that easier to do than leading the faculty here at the Institute. Please join me in welcoming President Rosenbaum.
Well, Joe, as usual, is always right. Welcome to one of the great universities of the world. Throughout its history, the California Institute of Technology has ventured into unexplored realms, defining new fields in science and engineering, and pushing interdisciplinary boundaries in the service of discovery. We are fearless in attacking large and important problems at scale, from the nature of the chemical bond, to the detection of gravitational waves, to the structure of the brain. Caltech's commitment to scientific leadership is notably expressed in the fabrication and operation of instrumentation that reveals nature in unexpected dimensions, whether through the world's largest telescopes, rovers sampling sedimentary rocks on Mars, planetary probes hurtling out of the heliosphere into interstellar space, a seismological network to provide early earthquake warnings, or the development of polymeric heart valves to improve human health. The audacity and ambition of your new intellectual community aligns and knits together Caltech students, faculty, and staff. Together, we work to set the example of what the intertwined missions of research and education can accomplish. Commencement speeches, claimed cartoonist Gary Trudeau, were invented largely in the belief that outgoing college students should never be released into the world until they have been properly sedated. By contrast, convocation speeches offer the opportunity to awaken entering students to the manifold opportunities offered in their new academic setting. But the pathways are not always clearly marked, and there are many things that you cannot learn except by exploring and experimenting. In this welcome, I should like to offer a few guideposts along the road of your explorations. You are part of an extraordinarily diverse group of students. The 235 of you who comprise the undergraduate class of 2023 join an undergraduate student body drawn from states across the United States and scores of different countries around the world. Our graduate student body is even more diverse in terms of the countries represented. A heterogeneous assembly of scholars, students and faculty alike, necessarily brings to bear a broad range of perspectives and methodologies to the problems of the day and for the ages. This diverse set of scholars, namely you, your peers, and your teachers, must be nurtured in an environment in which you are free to express your ideas boldly and fully, and have those ideas challenged and rebutted, shaped and honed. A commitment to data-driven inquiry, a belief in the primacy of truth, and the experience of enlarging your world intellectually and socially leads to transformation. You will face, however, the normal human tendency to narrow your world and seek comfort through closest association with those who look like you and think like you. The first guidepost about securing the most from your education, then, is the necessity to engage with a wide diversity of peers and teachers, to venture outside the comfort zone of your house, your option, and your division, and together to test and sharpen your ideas. There is an old proverb that if a book falls from a high shelf and hits you on the head and makes an empty sound, then it may not be the fault of the book. You will crack open many books as you master the intricacies of science and engineering, but a full resident education requires much more. You need to move beyond simple coursework and delve deeply into a subject at the boundaries of discovery, an opportunity afforded by performing research, both in the summer through SURF, as you will hear about today, and during the year. You need to understand other cultures and perspectives, perhaps firsthand through study abroad. You need to take advantage of theater and art and music on campus to explore Pasadena's treasures, the Huntington Library and Gardens, located less than a mile away, and the Norton Simon Museum, and to sample the cultural accoutrements of the second largest city in the United States, Los Angeles. Science, technology, and the arts must work together to find solutions for the challenges we face as a society. The poet William Carlos Williams wrote, "It is difficult to get the news from poems, yet men die miserably every day for lack of what is found there." A humanistic education helps us to function as life thrusts us into situations where we have to conceive problems outside of the structures that define them. It provides us with an elasticity of thought and familiarity of experience not fully our own, while challenging us to define the essence of what we believe. You are about to enter into a world rich in tradition and profoundly connected to the greatest achievements of humanity. It is the start of a lifelong relationship with Caltech that will evolve and deepen as you progress from student to alum. Most exciting, it is a dynamic world that is ready to be sculpted by the power of your ideas. Your parents, siblings, loved ones, and friends have helped prepare you for this grand adventure, and they will continue to be there, albeit at more of a distance, to help you discern the guideposts of your college education. I wish you the joy of discovery as you commence your journey.
Thank you, Tom. Caltech is a place that's famous for getting right down to the matter at hand with relatively little fanfare, and that's what we're going to do next. Don't worry, we're not going to be having a lecture. We'll have plenty of that later on. The matter at hand this afternoon is the many opportunities for extracurricular research that are available to undergraduate students, mentoring opportunities for graduate students, and the opportunities for faculty to share the excitement of discovery and the development of technology in their laboratories. As you just heard from President Rosenbaum, Caltech is a place that's infused with a spirit of inquiry and discovery through research. I like to put it this way: coming to Caltech and not participating in research is like going to a great restaurant and only ordering from the menu. So, to give you an idea of all the things that are not on the menu here, I've invited Dr. Candice Ripich, the Director of Student Faculty Programs, to give you an introduction to our Summer Undergraduate Research Program, or SURF, as we call it. Dr. Ripich has been a valued member of the community at Caltech for the past 18 years and has led the Student Faculty Program Office for the past 12. Candace is responsible for the management of 10 undergraduate research programs at Caltech and also at NASA's Jet Propulsion Laboratory, just up the road here. A little place you might have heard of. It serves about 900 students annually. This is a very substantial activity that's really become a very integral part of the experience for not just the undergraduate students, but their mentors and professors, as you'll hear later today. Candace has been very active in this field. She just ended her 2-year term as the president of the Southern California Conference on Undergraduate Researchers, and she has her education doctorate from USC. Please help me welcome Dr. Ripich.
Good afternoon and welcome, everyone. Joe, thank you very much for this opportunity to highlight our undergraduate research programs here at Caltech. I hope today's speakers will inspire our new undergraduates to get involved early and often in research projects and will motivate our new graduate students and postdocs to become research mentors during your time here. In both cases, I think you'll find that your participation will enrich your Caltech experience and will help you prepare for your future endeavors. So Caltech's emphasis on undergraduate research dates back to our earliest of years as an institute when Arthur Amos Noyes made the completion of 9 units of independent research a graduation requirement for all chemistry majors. You might recognize these folks, at least maybe the one on the left, who is Linus Pauling. Dr. Pauling was known for his work in quantum chemistry and molecular biology. And the person on the right is Edwin McMillan, who was an undergraduate at Caltech. In 1925, Pauling was finishing up his PhD when he met and started doing research with McMillan, who was only a freshman. Their work together resulted in a co-authored paper in the Journal of the American Chemical Society entitled An X-ray Study of the Alloys of Lead and Thallium. McMillan, the freshman, was the lead author. Of course, both Pauling and McMillan went on to win Nobel Prizes in chemistry, setting very high expectations and standards for all future undergraduate researchers and their mentors, right? But fast forward to today. Doing research is an essential part of the Caltech undergraduate experience. A low student-faculty ratio of 3-to-1, along with our relationship with NASA's Jet Propulsion Laboratory, provides extraordinary opportunities for students to get involved in the research enterprise. Nearly all of our entering first-year students expect to do research during their time here, and most of you will. 90% of all undergraduates participate in at least one research project while at Caltech. You can do this through the curriculum, for work study, a senior thesis, or even an off-campus internship. But as was mentioned, most students choose to at least do one project through SURF, the Summer Undergraduate Research Fellowships Program. Approximately half of all eligible Caltech students SURF each summer. And the opportunities are available early. 60% of last year's freshman class did a SURF this summer. But why focus on involving and getting involved in research, undergraduates in research? Well, we know that undergraduate research is one of 12 high-impact practices known to support student engagement and retention. Students who do research have higher graduation rates and go on to graduate school in higher rates than their peers who don't. Students report having stronger connections with faculty and their research groups, which results in a higher level of satisfaction with their overall undergraduate experience. Through SURF, students have an opportunity to learn from others in the research setting. Faculty, postdocs, graduate students, and research scientists provide important mentoring, critical mentoring, guidance, and advice. And we know that good mentoring matters. Undergraduates who work with a research mentor have better experiences and stronger learning outcomes as a result. This is especially significant for women, first-generation, and underrepresented students in STEM fields. For our new graduate students and postdocs here today, I'm betting that most, if not all of you, did research as an undergraduate. I'm sure you can think back to your own undergraduate experience and identify the impact that your mentors and research group members had on you. And mentors benefit from working with students as well. You will gain important advising, teaching, and mentoring skills that will serve you well. And just like the undergraduates, those who mentor students have a higher level of satisfaction with their own academic work and work experience that comes with the opportunity to make a positive impact on the next generation of scientists. So to wrap up, undergraduate research at Caltech is a commitment. It's a commitment to training the next generation of scientists and engineers. It's a commitment to preparing future faculty and world leaders to work with others. And it's a commitment to actively supporting student access, equity, and inclusion in STEM. So where do you all go from here? If you're an undergraduate, there are a couple of things you can do this fall. One is attend this week's session on SURF, so you can think about what you can do this term to prepare for a research experience next summer. You can attend SURF Seminar Day on October 19th. This is where students who did research this summer will be presenting their projects and their results. And you can attend the JPL Explore program starting in October, where we will bring JPL scientists and engineers down on campus to talk about their research and give you an opportunity to meet them and find out what opportunities are available up at JPL. For graduate students, the first thing, if you're interested in mentoring, and I hope you are, you talk to your PI about the role of undergraduates in your research group. Find out what generally people do and how you can get involved. You can volunteer to serve as a session chair for SURF Seminar Day and support those students who are presenting their research. And I urge you to get involved in the wide array of opportunities at Caltech that support your professional development as a mentor, teacher, and advisor, offered through our office, the Center for Teaching, Learning, and Outreach, and several other offices on campus. So I want to leave you with one last picture. This is Dr. Frances Arnold, the Linus Pauling Professor of Chemical Engineering and the 2018 Nobel Prize winner in chemistry. Dr. Arnold continues the tradition of excellence in research and education that Noyes and Pauling helped establish at Caltech nearly a century ago. During her time here, she has been committed to having undergraduates in her lab, and she has mentored over 110 undergraduate researchers. In an interview recently, she said, "It's the students and their wild ideas that push the lab forward. Young scientists love to generate ideas." So as you start your Caltech journey, I hope you will follow in the tradition of Pauling, Macmillan, and Arnold. Immerse yourself in the research, generate wild ideas, and push the frontiers of knowledge forward. All right, so now for the fun stuff. I'm going to bring up Eric Moreno. Eric is a junior majoring in physics. This summer, he completed his second SURF project under the mentorship of Dr. Harvey Newman. Eric is a Mellon Mays Fellow, a member of Ricketts House, and in his free time likes to play the piano, bass guitar, and double bass. And he's going to tell us a little bit about his research these past 2 years. Eric?
Hi, everybody. So to start off, I want to tell you why I think it's really bizarre that we're here. So to explain this, let's start at the beginning of everything, the beginning of the universe. So if you use general relativity and you extrapolate backwards to the beginning of the universe, we know that the universe started as a singularity, a point of infinite density which contained all of the space-time and mass in the universe. Now, if this isn't weird enough already, which it should be, it gets stranger than that. So the inflation of this singularity, which we call the Big Bang, should have created equal amounts of matter and antimatter in our universe. However, when we look around our universe today, the only thing we see around is matter, and we don't see any antimatter. And we wonder, why is that? But it gets even stranger. So with the Big Bang, we know for a fact that 1 part per billion of the mass of the singularity that we had still exists today in our universe. That 1 part per billion is what we see around us. It's what makes up planets, stars, galaxies. That 1 part per billion cosmic fluke is the reason you're listening to me right now. That's weird, okay? And no current laws of physics are able to explain that. So as physicists, we wonder, what is going on and what are we missing? That's why we have a collaboration at the Large Hadron Collider to study the fundamentals of particle physics. I work at the Large Hadron Collider, and it's in collaboration with the European Nuclear Agency. And the Large Hadron Collider is the world's most powerful particle collider. At 27 kilometers in length, it's a massive particle collider, the most powerful one that we have in the world, and it's the largest piece of machinery that humans have ever built. So what happens in this collider? Basically, we have protons that we boost or accelerate to near the speed of light speeds, and then we collide them in the detector at around 13 trillion electron volts at around 1 billion times per second. What these high energies allow us to do is they allow us to explore and create new particles, like fermions, hadrons, and bosons, which we're then able to further study in our detectors. So you need a detector. We have 4 main detectors on the LHC. I work with one of the 4 main detectors, which is the compact Muon solenoid detector, or CMS detector. It's built around a huge high-field magnet, and the size of it is actually pretty impressive. So if you scaled this up to actual size, this picture would be 5 stories high, and it would weigh 14,000 tons. So it's a massive detector. And what we do is, in the middle of the detector, we have our beams of protons that come in and collide with other protons. And everywhere around it, in the radial direction, we have different kinds of trackers, calorimeters, and pixel detectors for us to be able to identify what particles we saw inside of the collisions. And to do that, we measure the energy and momenta of different decay products, like photons, electrons, and muons inside of the collisions. You have your proton going in, and it's been accelerated to like 99.99999% the speed of light, and it's coming in through the detector, or through the collider, and you have another proton that's coming in the opposite direction, and they're coming in really fast, and then they just collide, and they make a bunch of new particles that go everywhere. And we're trying to study these particles, and they're registered as hits inside of our detector, and we're trying to study like the energy and momenta and the different tracks that these particles took. So the real research that we're doing out at CERN is studying very rare events. Most of the events that we see in the detector are actually known physics. We can explain them fully with our theoretical predictions. But there are these 1 in a billion or 1 in a trillion kind of events that we see every once in a while that are like a needle in a haystack that we're probing for that don't exactly line up with our theoretical predictions. So the whole game that we're playing here is, how do we identify these needle in a haystack events so that we can compare them to our theoretical models and see where we're wrong about our understanding of the universe. So one of the rare particles that we were probing for was the Higgs boson, otherwise known as the God particle, otherwise known as the only reason you weigh anything at all, because it's the particle that gives matter its mass. The Higgs boson was the last missing piece of the standard model of particle physics, and in 2012, we found the Higgs boson with the CMS and ATLAS collaborations at the LHC. So if you look at this plot, it looks kind of boring, but it's actually one of the most amazing discoveries of 21st century physics, because you have your normal background signature, but then you have a tiny little bump at 125 GeV. And that's exactly where we were expecting to see the Higgs boson. But there's a problem, right? We don't know if this is exactly the same Higgs boson as predicted by the standard model of particle physics. So there was further work required to verify that this was the exact Higgs boson that we predicted. So that's my research. I'm studying Higgs decays in order to be able to identify which events inside of the collider, the needle in a haystack kind of events, which events are actually Higgs bosons and which events are background signals. So if you look at the top picture, at the primary vertex, or PV, we would have a Higgs boson, which most likely decays into some heavy quarks, which fly a certain flight distance on the order of millimeters, and further decay into showers of particles at secondary vertices. And these literally look like showers of particles, like they look like cones of particles that are going out in every direction. But the problem is that these cones of particles look really similar to a bunch of other decaying particles, like gluons, B quarks, and W bosons. So my research involves applying machine learning algorithms and architectures to better understand the substructure of Higgs boson decays. And then when we better understand that substructure, we can more easily identify Higgs bosons. And that's really important because if we more accurately identify which events inside of the collider contain Higgs bosons, then we can more accurately say the properties of the Higgs bosons by studying these events. And so that's my research. My undergraduate experience has been substantially improved by this research. I would say that first, it's a creative outlet for me to get away from all of my problem sets, as weird as that sounds. It's actually a kind of project that I'm really interested in and that I can leave the problem sets for a while and engage in my research. Also, it's taught me a lot of skills that I'm going to need to use for whatever career I take in the future, different programming languages, different machine learning frameworks, different data analysis techniques. We also are part of a large collaborative atmosphere of a team of scientists from across the world. There are 3,000 scientists in CMS itself. So I'm collaborating on a daily basis with scientists from Europe, from Asia, all over the world. I'm up all night talking to people on my Skype. And I would really say that getting your hands into a research field that you're really passionate about can inspire your curiosity and can really be a valuable experience. So I encourage everybody to try it. So with that out of the way, telling you about myself, I want to ask you some questions. So in your prospective scientific fields, do you feel like all of the major mysteries have been solved? Do you feel like we've stood on the shoulders of giants and peered as far as we can see? I'd argue that the answer to these questions are not at all. And there's this cynicism that we have in society that everything that the world is boring and that everything has been discovered. But really, like, has it really? Like, from where I'm looking, like, we're at the top of the iceberg and we have no clue what's going on. And we're really more confused than we ever have. And we've been placed in this jigsaw puzzle created by this madman, and we've existed in it long enough to think that it's normal, but it's not normal whatsoever. Like, our world is really weird. So I encourage you to let this be the catalyst for you to engage in undergraduate research. Don't let this scare you. Let this motivate you. Undergraduate research is an amazing opportunity. And what you're going to get out of it is, first, some skills that you can apply for the rest of your life in any field that you go into. Second, you're going to meet some amazing and supportive faculty, postdocs, and grad students that are willing to help you and mentor you through your project. And in the end, what you're going to get is a sense of contributing to something more than yourself. You've contributed to the goals of humanity. So thank you, and that's my research.
Pretty impressive, right? And just as a reminder, Eric is just a rising junior. He started this amazing research at the end of his freshman year, and hopefully next year we'll be going to CERN to continue his work. If you're interested in learning more about Eric's research, I invite you to join us at SURF Seminar Day in October, where he's going to talk about his full project and his findings. So our next speaker that I'd like to bring up is Morgan Hooper. Morgan is a fourth-year graduate student studying in the Mckenna research group. She looks at fluid structure interactions in bluff body wakes. She came to Caltech from the University of Toronto and has mentored undergraduate summer researchers for the past 2 years. Not only is she a talented researcher and mentor, but she's also a talented baker who's on the search for the perfect technique for sourdough bread. So, Morgan, come on up.
All right, hi everyone. I'm Morgan Hooper, and as Candace mentioned, I'm about to start my 4th year of graduate study here at Caltech in the Aerospace department. Throughout my undergraduate career at the University of Toronto, I was privileged to have taken part in several undergraduate research experiences and professional internships. Those experiences have certainly shaped the researcher and the person that I have become, so I find immense value in paying that forward as a graduate student mentor myself. I've found that mentoring undergraduate researchers not only pays off for them, I really hope, and seems like it does, but it also continues to pay off for me in a variety of ways that I'd really like to share with you today. First, and probably most obviously, undergraduate research gives students the opportunity to try research on for size, to see how it fits, and to get better acquainted with their professional selves. As a mentor, observing and facilitating that process can be extremely rewarding. I've watched students face and overcome challenges that I myself have recently faced, grapple with concepts that I continue to find challenging, and I hope that I've been able to help them achieve success despite setbacks. I've also learned a lot in the process. In teaching someone else about the interplay of various theories on the structure of turbulence, how to read a research paper, or how to give a captivating presentation, I've had the opportunity to reflect on those things myself and improve my own skills and knowledge. It has also, I think, greatly improved my effectiveness as a STEM educator. One particular mentorship opportunity that has strongly impacted my outlook on STEM teaching and learning is the Base 11 Aerospace Mentorship Program. Base 11 is a nonprofit group that works to establish a pipeline for interested students at local community colleges to 4-year programs and eventually careers in aerospace and other STEM fields. The students that I've met through this program inspire me, because although their paths into a career in research are often non-traditional, they're also some of the most curious and highly motivated students that I've worked with. I find sharing in all of my students' successes and taking pride not only in their work, but also in their personal and professional growth to be extremely motivating for my own work and career. One possibly less obvious benefit of mentoring undergraduate researchers is the sense of community that it can create within a research group. During a PhD, there's a lot of emphasis on working independently. The core of the process is for each person to carve out an individual niche in the landscape of a field and to become an expert in that particular subject. When you mentor an undergraduate researcher, however, that scope sort of widens to include not only technical achievement, but also communication and collaboration with that person. You're required to transfer some of your knowledge to someone who's not only new to your field, but possibly also new to science or engineering as a whole. Making a habit of communicating what you're working on, why, and in what way the current challenges are can actually go a long way to improving communication and collaboration in the scope of your research group and beyond. It also provides the opportunity for you as a graduate student or as a postdoc to really influence and sort of start to build a community that you want to be a part of. As a mentor, you have a lot of power to dictate what kind of communicator your students are going to become, how they interact with you, how they interact with other researchers in your group, and with other scientists at large. You also have a direct impact on making sure that they feel included in your research group, in your field, both as a scientist or engineer, but also as a whole person. For example, I've personally mentored many students who identify as female, and in sharing the similarities in our journeys, my own challenges, successes, and role models, and bolstering confidence that we do all in fact belong here, I hope I've contributed to making them feel included in our group, the department, and our field at large. This opportunity to affect and possibly even improve the culture and communication style within a research group is the last benefit of undergraduate mentorship that I'd like to point out today. Mentoring undergraduate researchers has been an incredible learning experience for me, and I believe that it's going to serve me very well moving forward in my own career. Teaching and motivating students, planning and supervising a research project, even if it's limited in scope, and helping a student adapt to the inevitable ups and downs inherent in every research endeavor has both improved my confidence in the skills and perspective that I've gained during my time here as a student, but also contributed contributed to preparing me to run my own research group, lead a project, or otherwise effectively collaborate with other engineers and scientists. I feel immensely fortunate to have had the opportunity to practice these interpersonal skills in addition to the technical skills that I think we can all hope to attain while we're here. So on that note, to the graduate students and postdocs in the audience, I really want to urge you to get involved in undergraduate mentorship. Caltech offers many programs, workshops, seminars, and even a sort of formal program that can lead to a transcript notation on the topic of mentorship, all of which I highly recommend you access. Talk to your PI if you're interested in mentoring an undergraduate researcher over the summer, and definitely get involved in some of these great programs offered by the CTLO and by the Center for Diversity during the year. To close, I think it would be unfair of me not to mention the principal reason that I enjoy mentoring undergraduate researchers. It's honestly just fun. We had a great time this summer. Taking a break from your own narrow slice of the world to think about another problem, even if it's just for 10 weeks over the summer, can often provide some much needed perspective. And sharing what you're working on with another person, paying your motivation, curiosity, and inspiration forward, helps to remind me, at least, why we're all here.
Thank you so much, Morgan. The Base 11 program is a wonderful example of outreach efforts that we have here at Caltech. And again, hopefully most of you will get involved in those. Our final speaker is Dr. David Van Valen. As an undergraduate at MIT, Dr. Van Valen came to Caltech for 2 summers to do research. He then returned to do his MD PhD in the joint Caltech-UCLA program. And in 2018, after a postdoctoral fellowship at Stanford, he joined the Caltech faculty as an assistant professor in biology. In his short time back, he's already mentored 12 undergraduate researchers. As a former undergraduate researcher, a graduate student mentor, and a faculty mentor, he has a unique experience on how undergraduate research can make an impact on all those involved. Dr. Van Valen?
Thank you so much for the invitation to speak. I actually started college about 20 years ago, and I find it quite poetic that 20 years after starting my scientific journey, I'm being asked to help usher in the next generation of scientists at our country's best institute of technology. Yeah, the theme of tonight is undergraduate research, and for those who know me, this is a topic that holds a special place in my heart because my research career actually started at Caltech when I was an undergraduate. And so this is a picture of me back in, I want to say the summer of 2001. So in 2001 and 2002, I was a SURF student here at Caltech. The program I worked under was called MURF, which I think is called WAVE now. And the experiences that I had are what led me to live a life in science. And it was only after I got to experience research at other places that I appreciated how special the Caltech research experience is. No other place lets you jump directly to the frontier of human knowledge, while at the same time providing mentorship from arguably some of the best scientists who've ever lived. Caltech's ability to offer such an experience for students who are at the very beginning of their scientific journey is what makes it special. I understand there are 3 different audiences here, undergraduates, graduate students, and postdoctoral fellows. I've prepared separate but brief messages for each of them. For the undergraduates, while Caltech is renowned for our difficult coursework, and we do expect you to do well, our true value is the research experience. Take advantage of it. Join a lab and take the opportunity to truly engage with the research community on campus, not just during the summer in a SURF, but throughout the entire year. The value you'll get out of such an undertaking, from the science you'll learn, the impact you'll make, and the mentorship you'll receive, is far greater than the opportunity cost of whatever courses you may miss out on. To the graduate students, undergraduate researchers are a tremendous resource for increasing the pace at which you can do science. Undergraduates have made essential contributions in my lab. This slide shows artificial intelligence-empowered software that my lab has developed for tracking single cells in microscopy movies. While there are some mistakes, this algorithm is by far and away the state of the art in biomedical image analysis. Keep in mind, my research group has been active for only a year, and a team of undergraduates was essential in achieving results this quickly. And for the postdocs, you're in a very different stage of your career, and you'll find that time goes by very fast. Discoveries come, papers get written, and before you know it, you're looking for the next step in your scientific adventure. In the midst of all of this, I would encourage you to remember one thing. The students are the point. They are why the academy exists. As you get older, like I have, you'll come to realize that the real measure of a scientist's impact is not the papers they've produced, but rather the success of their students. You're now in a unique position to create the experiences the next generation of scientists will need if they're to solve the pressing challenges facing humanity. Think back at all the mentors you've had that encouraged you when you were down or pushed you to exceed what you thought were your limits. You now have the chance to be that person for someone else. Isn't that wonderful? So I think that's all I had to say, so I'll stop talking. Everyone who's here should give themselves a pat on the back for making it this far, and I wish all of you the best of luck during what I hope are the best years of your life.
Well, that was fantastic, and I'd just like to thank Candace, Eric, Morgan, and Professor Van Valen for their thoughts and sharing their experiences. And just think, in a couple of years, some of you will be up here on the stage. How about that, huh? Thank you, guys. Now, we've heard about the tremendous opportunities and benefits of research at Caltech, but in fact, there are many other opportunities outside the classroom and the laboratory. These include recreational activities such as athletics, music, theater. There are many clubs and informal extracurricular activities, and there's just having fun. And I would like to encourage all of you to take advantage of that during your time here. And you're going to be learning about some of those opportunities during the upcoming orientation and, of course, throughout the year. But what we're going to have next is a short video to get you started thinking about some of the things you can be involved with here.
I'm Kelvin Bates. When I'm not in the lab, I end up spending a lot of my time doing theater. When I got here, I never thought I'd be doing any more theater in my life, really. I figured I'm going to Caltech, where they do science. That's all I'm going to do. I better focus and buckle down from here on out. And I was pleasantly surprised to find that there was an active community doing theater here and plenty of opportunities for people to join in. Most recently, I was in Boldly Go, which was a Star Trek parody musical written by a graduate student here and his brother. It was a ton of fun. I played Captain Kirk. It takes a lot of time, but it creates a really nice sense of community. My advisors have both been very supportive, and they both come to shows that I've put on. For me, it's really important to have some sort of creative outlet. It keeps me more focused and productive when I am trying to do my work in lab, which does still happen.
Hi guys, I'm Bianca Lepe, and I realized that I loved traveling when I was introduced to the Caltech Y. In particular, I was introduced to a program called India Key Coach, which allowed me as a Frosh to travel to India and learn a little bit about the culture of India. I really learned a lot about the global perspective. Since coming to Caltech, I've been able to go to India twice. I've traveled to London in the UK, and I've also been to the Galapagos. But I've also known friends who've gone places like backpacking in South America, traveling through Indonesia, as well as traveling across Europe. So I would definitely say that the bounds are limitless. Wherever you'd want to go, there's a possibility of going there.
My name is Brittany Person. I'm on the swim team and water polo team. I knew I needed to swim because I kind of go crazy when I don't swim. I couldn't leave behind swimming. I really needed like the structure of a varsity team. I'd say a lot of us are kind of weird, kind of quirky, but that's really fun in my opinion. Half the people just kind of jumped in and they're having fun and they just work hard. Sometimes they work harder than anyone else. I love coming to practice and working with them every day. I love going to breakfast afterwards with them, and I love at conference championships cheering them on and having them cheer me on. And really the team atmosphere is amazing, and I've never experienced anything like it.
Hi, I'm Michael Post. When I first got to Caltech, I had the opportunity to join the Graduate Student Council, or the GSC, and as chair, I got to lead this whole organization, advocating for a grad student's academic life, its extracurricular life, and its social life. One of the cooler things I got to do is actually have a battle of the bands. We decided to call it Tech Stock. It's turned into this really epic all-day music festival. And it was also a really amazing avenue to meet more faculty. All of the leadership administration positions are filled by faculty, and their doors are open. You can just go talk to them. It was a really great experience and opportunity to be able to follow both my scientific passions in lab and also my passion for leadership through this organization.
Hi, I'm Nick Trank.
Hi, I'm Tiffany, and we were part of the team that organized the very first Science Olympiad state competition here at Caltech.
Usually the state competitions are run at local high schools, but this time we managed by talking to administration and getting a lot of faculty support to bring it here on campus. We brought a lot of eager middle school and high school students to compete. We got to interact with them, they all got to see the great Caltech campus, and overall it was a lot of fun.
Everyone was really excited because they were at Caltech and also they were about to compete. Students just got to enjoy their passions. They got to spend an entire day doing science, working really hard with their team and watching all their efforts pay off.
It's been so much fun working with all the Caltech students to make this possible.
My name is Nishant Desai, and I'm one of the house presidents. As Caltech students, it's kind of interesting that we get to run our own houses. As a part of that, we have to make sure that we do it right and we do it smoothly, and that's sort of what I'm here to do. Coming into Caltech, I had never really thought of student government as something that really appealed to me. It was out of the blue, something that I really found a passion for, and really made me realize that it's important to sort of embrace a diversity of opinions. Not just your own, it's important to listen to people that disagree with you. Probably more than it is important to listen to people who agree with you. That's like something that I've learned that I didn't really expect to, and something that I'm definitely going to take out of Caltech.
I'm Michelle Wong, and I'm on the Caltech women's basketball team. You have your community in your house, you have your community in your study groups, but basketball is like a completely different dynamic. It challenges you in different ways. I don't always want to be studying, so basketball is like a good release from that. It also just gives me more energy. Sometimes when I come back from practice, I feel more energized from working out, and that kind of motivates me to do my other work. So right now I'm in Brown Gym. It's become a very comforting place for me, especially last year after our 2 conference wins, and the celebration that happened in this gym, I think, is definitely grown to be a very positive atmosphere. The best part about being on the women's basketball team is how challenging it is. You basically have to tap into something else that I never really thought about before I came here.
My name is Sean Mckenna, and for a lot of my time at Caltech, I've been involved with ASCID, which stands for the Associated Students of the California Institute of Technology. It's our student government on campus. I had various responsibilities, from like planning meetings to helping people when they want to have parties get all of ASCID's equipment. One of the things that everyone who's on the board of directors does is midnight donuts. At midnight on a random night in the middle of term, basically every undergraduate comes out onto the Olive Walk and demands donuts. It's really fun. For one night, I get to see literally everyone on campus in the same spot within 20 minutes, and I think that's a really cool experience that you definitely wouldn't have anywhere other than Caltech.
Hi, I am Nadia Herrera. I have been playing the violin since I was in 3rd grade, and honestly, it's another part of my life that you would consider as essential as waking up and eating every day. And coming here, I had no expectations for the music program because it is such a science-focused school. But what I encountered were very high-level musicians and people who are just absolutely wonderful to work with. And working in chamber groups so consistently just allows you to grow more as a musician. Once I get to the music house, it's like time stops. I stop worrying about my experiments and I can just play music and be very happy. I do spend all day in the lab. I think science, science, science. I wake up thinking science, I go to bed thinking science, and just, you know, every now and then being able to go to bed thinking I have a concert tomorrow is just, it's a change of scenery. It helps me keep touch with like that part of like my humanity, who I am, as opposed to like I'm a scientist and that's it.
I'm Rob Anderson.
I'm Adrian Costantino.
And we are here in the Formula SAE garage, the home of Caltech's first Formula SAE racing team, where we designed and built a complete electric vehicle from the ground up. And the part that I really enjoyed, I got to lead the direction of the club, but also just be able to interact with all the students and people in industry. It gave me that experience of pretty much a startup culture. Being able to fail and learn from all those mistakes was extremely valuable.
My favorite experience was doing all the design and then doing the simulations and really seeing how a lot of the theory that we learned actually apply to real engineering world.
The electric competition is very new. All the teams are kind of trying to figure things out. And even though things didn't work out too well at competition, it was one of the most fun and exciting parts about the whole club this year. We learned so much.
This summer I'm interning at SpaceX. All companies really look for people who have real hands-on experience.
Being a part of this club and founding it also got me my opportunity at SpaceX. I just kind of started with an idea I had, and Caltech really were supportive the whole entire way through it.
We have a small campus community, but that doesn't mean that there's nothing to do. It means that you want to do everything because you know everyone and you know everything that's going on, and it's also cool that you want to get involved in all of it.
Really, what I think is most important of being successful at Caltech is being open-minded and willing to try new things.
It's really easy to get involved. You have so many options. You don't have to be in the lab all the time. You have the opportunity to do so many other things at Caltech.